Hi everyone, welcome to the series Blast from the Past from IMS. In today's session, we are going to discuss question based on geometry. I am Dr. Nishant Gupta and let's start with the session. Guys, my advice is before you look at the solutions, try these questions by pausing the video and then look at the solution. So here's the first question on your screen. It says, in the figure, which is not drawn to scale given below, if AD equal to CD, AD equal to CD, which is also equal to BC. Angle BCE is 96 degree. This is 96 degree given. How much is the value of angle DBC? We need to find this angle. Now, in triangle ACD, AD equal to DC, which means it is an isosceles triangle. And in case of isosceles triangle, angle opposite to the equal sides are equal. So if I take this angle to be x degree, then this angle is also x degree. Angle opposite to the equal sides are also equal in case of isosceles triangle. Now, angle CDB is the exterior angle of triangle ACD. An exterior angle is nothing but the sum of two interior opposite angles. So this is equal to 2x. Now in triangle DBC, DC equal to CB, which means it is also an isosceles triangle. And in case of an isosceles triangle, angle opposite to equal sides are equal. So this means this is also 2x. Now finally, for triangle ABC, angle BCE is the exterior angle, and exterior angle is equal to the sum of two interior opposite angles, which is x plus 2x. So this is x plus 2x. That means 3x equal to 96 degree or x equal to 32 degree. But the question is not asking you the value of x. They are asking you what is the angle of DBC. So angle DBC is twice x. So angle DBC is twice x, which is also 2 into 32 or 60, 40. So option C here is the right answer. Next question says, consider obtuse angle triangles with sides 8, 15 and x centimeters. If x is an integer, then how many such triangles exist? For an obtuse angle triangle, where one angle is more than 90 and less than 180, so if we take this as A, B, C, here this is the largest side. Let's say in this case B, this is let's say C, and this side is A. So largest side square should be greater than sum of the square of other two sides. But the problem here is we know only two sides. We know one side has 8, the other side has 15, and the third side is x. So there are two possibilities. One, either 15 is the largest side, 15 is the largest side, or x is the largest side. So we'll take two cases separately. If 15 is the largest side, then 15 square should be greater than 8 square plus x square, which means 225 minus 64 should be greater than x square, and x square should be less than 161. Now, which means x should be less than under root 161, and under root 161 is 12.68. Even if you don't know the exact value of under root 161, what you can do, this value is some value which is more than 12 and less than 13, because 12 square is 144 and 13 square is 169. But does that mean x can take any value less than this? No, there's one more basic property that we use while solving the triangles question, that is difference of any two sides should be less than the third side, which means the difference of 15 minus 8 should be less than x. So x lies between 7 to 12 point something, and it is given that x is an integer. So x can be 8, 9, 10, 11 or 12. Remember, 12 here is acceptable because the value of x is 12 point something. So we can take any value less than 12 point something, integral value less than 12 point something. Now, the second case is if x is the largest side, then x square should be greater than 15 square plus 8 square, or x square should be greater than 225 plus 64, x square should be greater than 289, or x should be greater than 70. But again, there should be upper limit, and we also know that for any triangle, sum of any two sides should be greater than the third side, which means this x should be less than 15 plus 8. So x here lies between 17 to 23, excluding these. So the acceptable values of x are 18, 19, 20, 21 and 22. So in all, 5 triangles from this one. So basically, this gives me 5 plus 5, 10 such obtuse angle triangle with side 8, 15 and x. So answer option C is the right. Next question on your screen is, consider the triangle ABC shown in the following figure. BC is 12, BD is 9 and CD is 6. An angle BCD is this angle, is equal to angle BAC. Now the final question is, what is the ratio of the perimeter of triangle ADC to that of BDC? Now, in the given figure, triangle ABC, in triangle ABC and triangle BCD, angle A equal to angle C, given. It is given. Angle B is a common angle. It is a common angle. Okay. So by angle rule, these two triangles are similar. That means triangle ABC is similar to triangle CBD. Okay. And in similar triangles, ratio of corresponding sides are equal. So AB upon BC is equal to CB upon BD, which gives me AB as BC into BC upon BD. BC is given to me as 12, so it is 12 into 12 upon BD here is 9. So 3 3s are, 3 4s are, 3 4s are, this is 60. Now we got AB as 16 and we have BD as 9. That means AD is 7. AB is 16, BD is 9, so AD is 7. Now we can take AC upon BC. Again, we're taking from here. AC upon BC is equal to CD upon BD, which means AC equal to CD into BC upon BD. The value of CD here is 6, BC here is 12 and BD here is 9. So it is 3 3s are, 3 2s are, 3 4s are. So AC is 8. Now, the perimeter of triangle ADC is 7. It is 7 plus 8 plus 6 upon BDC, which is 9 plus 12 plus 6 equal to 21 upon 27, which can also be written as, if you cancel with 3, so 3 7s are, 3 9s are. So the answer is 7 by 9. Option A here is the right answer. Next question on your screen is again a very good question. It says, an equilateral triangle BPC is drawn inside a square ABCD. What is the value of angle APD in degree? So, first let's draw a square ABCD. Let's assume this is ABCD. Since it is a square, so all 4 sides are equal. All interior angles are 90 degree. Now, if we draw an equilateral triangle BPC inside this, that means there's a point P and BPC is an equilateral triangle. Equilateral triangle when all 3 sides are equal, which means all these given sides till now are equal. Remember, this P point will lie inside the square and not on side AD. Otherwise, it will not be an equilateral triangle. Now, this angle is 60 degree. It is an equilateral triangle. 60 degree. 60 degree. This angle will be 30 degree because the complete angle C is 90 degree. Same way, this part is 30 degree. We need to find angle APD. So, join APD. We need to find this one. Now, in triangle ABP, AB equal to BP. AB equal to BP, which means it is an isosceles triangle. And in case of an isosceles triangle, angle opposite to the equal sides are equal, which means these 2 angles must be equal. Okay. And sum of the 3 angles is 180 degree for any triangle. So, angle ABP is 30 degree, which means sum of the remaining 2 angles should be 150. That means angle BAP equal to angle BPA equal to 75 degree. Same way, in triangle CDP, CP equal to CD. Again, angle opposite to the equal sides will be equal. So, these 2 angles will also be 75, 75. With the same calculation, we can do this. Now, we need to find angle APD. This complete angle is 360, of which this is 75 part. This part is 75. This is 60. So, till now we have 210. So, angle APD is 360 minus 210 is equal to 150. So, option E here is the right answer. In the figure below, ABCDEF is a regular hexagon and angle AOF is 90 degree. So, AOF here is 90 degree. FO is parallel to ED. What is the ratio of the area of triangle AOF to that of the hexagon ABCDEF? Now, we all know that a regular hexagon is nothing but 6 equilateral triangles arranged in a specific order. So, if you draw these diagonals, you will see that these are 6 equilateral triangles. Also, in the given figure, triangle AOF is nothing but half of one of the equilateral triangle. So if this is one part, this is one part, this is two part, two part, two part, two part, and two part. Taking the area of one equilateral triangle to be two part, so half will be one part. Now the question is the ratio of the area of triangle AOF, which is one part, to the area of hexagon ABCDEF, which is 6 to the 12 part. So the answer is 1:12. So option A here is the right answer. Yes. So this question says, in the figure given below, not drawn to scale, ABC are the 3 points on the circle with center O. The chord BA is extended to the point T such that CT becomes tangent to the circle at point C. So this chord BA is extended to the point T and CT becomes the tangent. Now, also it is given to us that angle ATC is 30 degree. This one. Angle ACT is 50 degree. And find the angle BOA. So, angle BOA is this angle. Now, angle BAC, this angle is the exterior angle of triangle ATC. Angle BAC is the exterior angle of the triangle ATC, which is equal to the sum of two interior opposite angles. So that is 80 degree. First calculation. Second, we also know the angle made by a tangent and a chord is equal to the angle made by the same chord in the alternate segment of the circle. So, angle TCA is equal to angle ABC, alternate segment theorem. So, this is 50 degree. Now, in triangle ABC, the third angle will be 50 degree because sum of all three angles should be 180 degree. So, we have one angle as 80, the other angle as 50. So, the third angle should be 50 degree. We also know that angle subtended by a chord at the center is twice the angle subtended by the same chord at the circumference. So, angle BOA is twice angle BOA here is twice the angle BCA, which is 50 degree. So it is 2 into 50 or 100 degree. So option A here is the right answer. A circle with radius 2 is placed against right angle. Another smaller circle is also placed as shown in the adjoining figure. What is the radius of the smaller circle? So, the radius of the bigger circle here is 2. So, if I take the center as O and I drop the perpendiculars, so this will be 2, this will be 2, and it will be a square of 2 by 2. Now, the diagonal of this will be 2 root 2. We are using Pythagoras here. If I name them A, B, C, O, so OB here is nothing but under root O C square plus BC square, which is equal to 2 square plus 2 square under root. Okay, this is under root 8 or 2 root. Now, for the smaller triangle, let's take the radius as R. Now, if I take the center as O dash, so this will be R, this is radius R, and again this will be a square of r by r, and the diagonal will be r root 2, again using the Pythagoras. Now OP in the given figure is actually the radius of the circle, which is 2, plus radius of the smaller circle, which is r, plus this diagonal part, small diagonal part, this is r root 2, and OB we calculated as 2 root 2. So this is basically r root 2 plus 1 plus 2 equal to 2 root 2. Now taking this 2 to the right side, it is r root 2 plus 1 equal to 2 root 2 minus 2. This can also be written as, taking 2 common, root 2 minus 1 upon root 2 plus 1. Because my answer options are rationalized here, so we'll rationalize this. Let's multiply this with the root 2 minus 1 upon root 2 minus 1. No? So this is 2 into root 2 minus 1 square, which is root 2 square, plus 1 square minus 2 root 2 upon, in denominator we have root 2 plus 1 and root 2 minus 1, which is a plus b, a minus b, which is nothing but the identity of a square minus b square. So root 2 square is 2, 1 square is 1, so this is basically 1. So we get here 2 bracket 3 minus 2 root 2 upon 1, which can also be written as 6 minus 4 root 2. So option D here is the right answer. What is the distance in centimeters between two parallel chords of length 32 centimeter and 24 centimeters in a circle of radius 20 centimeter? Now there are two possible cases. One, if both the chords are in the different side of the center, they are on the different side of the center, or if they are on the same side of the center. Now, if I take the first case, so here, this, let's say O is the center, this is a chord of length 32, this taking as 24, the radius is given as 20. Now if I join here and drop a perpendicular from here, so if you drop a perpendicular from the center on a chord, it bisects the chord, which means this part is 12, this is given to me as 20 radius. So we can calculate this part. Let's name these points A, B, C. Here we can name them as D and E. So AB in this case is under root 20 square minus 12 square. Okay. So it is under root 400 minus 144, which is under root 256 or 60. AB is 16 in the first case. In the second case, in the first case, the second part is, if you join AE, this is, sorry, we are removing O from the here center. Let's assume this only A1. So AE is 20. Okay. This is perpendicular and will be 16, because if you join the midpoint of the chord to the center of the circle, it is perpendicular, or vice versa is also. So this is, now we need to calculate AD. AD is under root 20 square minus 16 square, which is under root 144 or 12. You can always use the triplets. These are triplets, 4 5s are 4 3s are 4 4s are. So this is a multiple of the triplet 3 4 5. So this will be 12. So in this case, the distance between the parallel chords will be 16 plus 12, which is 28. Okay. What if both the chords are on the same side of the center? Then drop a perpendicular. So it is, let's say this point is A, this is B, this is C, this is D, and E. Again, join AE and AC. So these are 20, 20 given to you. Radius of the circle. Now, BC was 12, DE was 16, and we just calculated that AB here is 16 using the same Pythagoras here. So AB here is 16 and AD is 12. Now the distance between the parallel chords will be this, which is BD, and BD here is AB minus AD, which is 16 minus 12. So option D here is the right answer, because there are two possibilities. Either both the chords will be on the same side of the center, or they can be on the opposite side of the center. In a triangle ABC, the length of side AB and AC are equal to 17.5 and 9 centimeters respectively. Let D be a point on the line segment BC such that AD is perpendicular to BC. If AD is 3 centimeter, then what is the radius in centimeter of the circle circumscribing the triangle ABC? So first, let's draw this to understand what they're saying. So let's say this is A, point B, point C. It is given that AB is 17.5, AC is 9. They're dropping a perpendicular from A on BC, let's say AD, and this is given to us as 3. Then what is the radius of the circumscribing circle? We need to calculate the radius of the circumscribing circle. We know that radius of a circumscribing circle, the radius of circumscribing circle is A into B into C upon 4 times the area of triangle. Okay. Now we don't have the base here. Let's assume the base to be B. Now the 3 sides are A, B, C. So side A is 17.5. B, we are taking as B. C here is 9 upon 4 times the area of triangle ABC. And area of triangle is half into base into height. So it is half into base, which is B, into height, which is 3. So B and B gets cancelled. Before you tempted to solve this, BD and CD part by using the Pythagoras here, just try this method. This is 2, 3. So this is 17 3s are 51, 52.5 by 2 or 26.2. So radius of the circumscribing circle is 26.25. Option E here is the right answer. A rectangular sheet of paper, when halved by folding it at the midpoint of its longer side, results in a rectangle. So we have a rectangular sheet here. Let's say this is length L, this is breadth B. Now we are folding it from the midpoint of the longer side to get another rectangle. What will this look like? It will be like this. Here this side will be L by 2 and this will become B. They say result in a rectangle whose longer and shorter sides are in the same proportion as the longer and shorter side of the original rectangle. So here, whatever is the ratio of the longer to the shorter side, the ratio of the longer and shorter side in the second rectangle will also be same. Now understand, if the longer side here is L in the bigger rectangle and the shorter side is taken as B, then it cannot be the longer side. L by 2 cannot be the longer side. Otherwise, it will not have the same ratio. How is this possible that L by B is also equal to L by 2 by B? Okay, that is not possible. So which means this B part will become the longer side now and this will become the shorter side, L by 2. Okay. If the shorter side of the rectangle is 2, if B equal to 2, then what is the area of the smaller rectangle? So let's place the value. It is L into L by 2 is equal to B square. B square is 4, B equal to 2. So L square by 2 equal to 2 square, or L square is actually 8. So this gives me L equal to 2 root. Remember, this is the value of L and not L by 2. We are supposed to calculate the area of the smaller rectangle. So area in this case would be L by 2 into B. L here is 2 root 2 by 2 into B is 2. The answer is 2 root. So option B here is the right answer. In this question, it is given, in the following figure, the diameter of the circles is 3 cm. AB and MN are two diameters such that MN is perpendicular to AB. So, AB and MN are perpendicular to each other and these are the diameters. In addition, CG is perpendicular to AB. This CG is perpendicular to AB such that AE is to EB is 1:2. Since the diameter is given to us as 3 cm, which means AE is 1 and EB is 2. Also, DF is perpendicular to MN. This is perpendicular to MN such that NL is to LM is 1:2. Again, this is one part and this should be 2. The length of DH in centimeters. So we need to find this part. Okay. First, understand, since these diameters are perpendicular to each other and then we have perpendicular lines, so this will be a basically square. See, AO is the radius. AO is 1.5, of which AE is 1, which means EO is equal to 0.5. This part is 0.5. So here NO is 1.5, NL is equal to 1, which means LO is also 0.5, which means this is a square of side 0.5. So EOLH is a square of side 0.5. Okay. Now, this is 0.5 or 1/2. We can write it 0.5 or 1/2. This is given to us 0.5 or 1/2. Now if I join OD, OD is the radius which is 1.5 or 3 by 2. So in triangle ODL, OD square is equal to OL square plus DL square. OD is 1.5, which can be written as 3 by 2. This square, OL is 1 by 2 square. We need to calculate DL square. This is 9 by 4 minus 1 by 4 equal to DL square, or DL equal to 8 by 4 under root 8 by 4 or under root 2. Okay. This is the length of DL and we are supposed to calculate DH. DH is nothing but DL minus HL. DL is root 2. HL is half. So this will be 2 root 2 minus 1 by 2. So option B here is the right answer. In this question, in the figure below, the rectangle is at corner measures 10 centimeter into 20 centimeter. The corner A of the rectangle is also a point on the circumference of the circle. What is the radius of the circle in centimeter? Let's assume the center of the circle to be O. Let's assume this to be O. And if I join, from O to these points, these are radius. This is radius. This is 90. So let us give the names like O, B, C. OB equal to OC equal to radius of the circle. Now, if you extend this point like this and join here, so this part, it is a rectangle of 10 by 20. So this part is 10. This is 20. That means if we are talking about this part, this will be R minus 10, radius minus 10, and this part will be R minus 20, radius minus 20, and the diagonal OA is equal to R. Now it is a rectangle, so we can use the Pythagoras here, which means R square is equal to R minus 10 square plus R minus 20 whole square. This is A square plus B square minus 2AB plus A square plus B square minus 2AB. We can cancel this R square and R square. So what is left? This is R square minus 20R plus minus 40R is 60R plus 100 plus 400 is plus 500 equal to 0. Now let's factorize this. It is R square minus 50R minus 10R plus 500 equal to 0. Take R common. R minus 50 minus 10, R minus 50 equal to 0. So we get R minus 10 into R minus 50 equal to 0. So either R minus 10 is equal to 0 or R minus 50 equal to 0, which gives us R equal to 10 or 50. But in this case, R cannot be 10, because if I take R as 10, then this part will be negative. R minus 20 will be negative, which is not possible. R equal to 10 means this corner will coincide with the circumference of the circle. That is not possible. So the answer here is option C. In this question, a punching machine is used to punch a circular hole of diameter 2 units from a square sheet of aluminum of width 2 units. So, this is 2 and the diameter of the circle is 2. If diameter is 2, then radius is 1. Radius is 1. The hole is punched such that the circular hole touches the corner at P, given here, of the square sheet, and the diameter of the hole originating at P is in line with the diagonals of the square. So, in this case, this is the diameter. Now, also, if you name these points as A and B, and if you join AB, AB is also the diameter, making an angle of 90 degree at the circumference. Okay. So, now if you look at it closely, it is nothing but semicircle. This part is a semicircle here. And then we have a triangle. Yeah. Semicircle and a triangle. Now the question is asking you the proportion of the sheet area that remained after punching. So sheet area that remained after punching. So we need to calculate the area of the square. That is 4. So first let's calculate the area which is remained after punching. That is 4 minus this yellow shaded region, which is half the area of circle. And area of circle is pi r square. So pi r square by 2. And we also need to subtract the area of this triangle, which is half into base. The diameter is 2 into height. Okay. So this is 4 minus pi by 2 minus 1, or 3 minus pi by 2, which can also be written as 6 minus pi by 2. This is the area remaining after punching. But the question is the proportion of the sheet that remains after punching. So, this 6 minus pi by 2 over the total area of the square sheet, that is 4. So, this will be 6 minus pi by 8. So, option B here is the right answer. Which says find the area of the part of the circle round punch falling outside the square sheet. So basically we want to calculate this part. And as discussed in the earlier question, this is area of the circle minus semicircle and the area of triangle. Okay. Or semicircle minus area of the triangle. So which is pi r square minus pi r square by 2. This part, first I am subtracting this part, the semicircle. And then we need to subtract this area of the triangle, which is half into base into height. So this is pi minus pi by 2. And this is minus 1, which is pi by 2 minus 1, or can be written as pi minus 2 by. So option D here is the right answer.